Okay, so today we're going to look at lesson 12. And lesson 12 is part of topic C. And topic C, the whole idea behind topic C is being able to compare ratios. So just a review, a ratio is a comparison of two things. Well, now we are comparing two ratios to see if they are equivalent. So number one says mixture 1 and mixture 2 are the same shade of purple. So if we were mixing this and we were making a paint color, for instance, we would be making the same color purple. But we need to use different numbers of parts blue paint and red paint. All right, so it says record what? The number of parts blue paint and the number of parts red paint in mixture 1. Because it's giving me the freedom to choose, I am just going to choose the numbers 2 to 3. Okay, they're not giving me the mixture, I'm just creating it. So 2 to 3. So now remember, I want to create the same shade. So let's look at B. Create mixture 2 by using blue paint and red paint. So we're using the same thing, blue paint and red paint. Make mixture 2 the same shade as mixture 1, but with a greater total amount of paint than mixture 1. So right now, our mixture 1 paint total is 5. So 2 parts blue and 3 parts red would give us a total of 5. So basically what they're asking us to do is to make a bigger batch of paint. So let's say instead of 1 batch of paint, I wanted to make 2 batches of paint. So I would need to multiply both of those numbers in the ratio by 2. So times 2 and I get 4, times 2 and I get 6. All right, so mixture 1 and mixture 2 are going to be the same color paint, purple, and mixture 2 is just going to have more paint in the cup. All right, so we're painting a bigger surface is what we're doing. All right, number 2, we're creating 2 new mixtures with the same number of parts red paint, but different parts blue paint. All right, so I'm going to create my first mixture. I'm just going to do 2 to 5. And again, in this case, I'm just making these numbers up. They're not giving me anything to go off of. All right. And then in the question, it says they have the same number of parts red. So I'm going to keep my parts red the same, but I'm going to have a different blue part. So instead of having a 2, I'm just going to put a 3. So again, they are allowing me to choose the numbers. I'm not getting them from anywhere. All right, so number 3 says complete the ratio tables for mixtures 1 and 2. So if you go back to mixture 1, my ratio is 2 to 3. And my ratio for mixture 2 is going to be 4 to 6. And I'm just getting this from problem number 1. All right, so if we make a ratio table, I'm going to double this, so double 2 and I would get 4, double 3 and I would get 6. All right, for the next one, I'm going to triple it, so I'm going to do times 3. So 2 times 3 is going to be 6, 3 times 3 is going to be 9, 2 times 4 is going to give me 8, and 3 times 4 is going to give me 12. So that's how I'm completing this table. I'm doing this as like 1 batch, 2 batches, 3 batches, 4 batches. And so I'm going back to my original every time, and I'm multiplying it by those numbers. 2 times 2 would give me 4, 2 times 3 would give me 6, 2 times 4 would give me 8, and I'm doing the same thing on the other side. All right, and we're going to do the same thing for mixture 2. So 4 times 2 would give me 8. 6 times 2 would give me 12. 4 times 3 would give me 12. 6 times 3 would give me 18. 4 times 4 would give me 16. And 6 times 4 would give me 24. So I'm just increasing the number of batches. So batch 1, batch 2, batch 3, and batch 4. All right, now it's asking me to graph the ratio relationship for mixture 1 in one color, and then graph the ratio relationship for mixture 2 in a different color. And it's telling us to use the tables from problem 3. So I'm going to choose a color. I'm going to do mixture 1 in red, and I'm going to plot those on the graph. So I have, and I'm not sure why there are some dots already on here, but that's okay. The purple can go with mixture 2. So we'll do the red ones, 2 to 3. So here's 1 dot, and then 4 to 6, and then I have 6 to 9, and then I have 8 to 12. All right, and then if I change to purple, my first dot on there is going to be 4, 6. So I'm going to plot 4, 6. And then I'm going to plot 8, 12. That's the next R pair. And then I'm going to plot 12, 18. Oh, I'm off on that one. Erase. All right, so 12, I'm trying to stay on here, 12. And I'm going up to 18, and I'm plotting that point right there. And then I can erase that line. All right, and then the last one would be 16, so I'm going to stay on this line, 16 to 24. It should be right here. And you guys should be seeing that if I were to go ahead and connect all those dots, they would all be in a straight line. So what this is telling us is that the ratio in mixture 1 is equivalent to the ratio in mixture 2. So the two ratios are equivalent. All right, so if we were comparing them, they have the same ratio. They're equivalent. So 2 to 3 is equivalent to 4 to 6. So we're looking at 2 different ratios. And because all of the points will end up on the same line, they are equivalent to each other. All right, let's look at mixture 3 and 4. So now we're going to go back to the original question. So mixture 3, I said my ratio was 2 to 5, and mixture 4 is 3 to 5. So this one is going to be 2 to 5, and this one is going to be 3 to 5. And again, I'm just going to follow the same pattern I did with the first one. That's 1 batch. Next would be 2 batches, so I would need to multiply each one of the numbers by 2. 2 times 2 is 4, 2 times 5 is 10, and then times 3. 3 times 2 is 6, 5 times 3 is 15, and then 2 times 4 is 8, 5 times 4 is 20. And then I'm going to do the same thing for mixture 4, so this would be 1 batch. 2 batches, I would need to multiply everything by 2, so this would be 6 and 10. 3 batches, I would need to multiply everything by 3, 9 and 15. And then the last one would be times 4. So 3 times 4 is 12, and 5 times 4 is 20. All right, so it's the same thing. It wants me to graph mixture 3 in one color and graph mixture 4 in a different color. So I'm going to do it again. I'm going to do mixture 3 in red. I'm going to do this one in red. So we have 2, 5. So 2, I find 2, and then I go up to a 5, and I put a dot. And you can erase that line. It just kind of helps me stay in line. So then I have 4, and it goes to 10. And then again, I'm going to erase that line. All right, and then I have 6 to 15. So 6, go up to 15, and then I'm going to put my dot. And then the last one, 8, and I'm going to go up to 20 on this one. And I'm getting these numbers from the table. Oh, I'm trying to erase those lines. Okay, so there's mixture 3, and that's my red one. Now I'm going to do mixture 4, and we can go ahead and do that one in purple too. So we'll do this one in purple. 3 goes with 5. Okay, 6 goes with 10. 9 goes with 15. And 12 goes with 20. 12 goes with 20. Then I'm going to go ahead and erase this. And what you should be noticing is that on this one, I can't draw a highlighted line and show all the points connected. There are two separate lines. You can see that I have a line through my purple points, and then I also have another line through my red points. So what is this telling us? This is telling us that the ratios 2 to 5, so this ratio 2 to 5 is not equal to the other ratio 3 to 5. So they are not equivalent because the points are not falling on the same line. They each have a different line with their points, but they're not falling on one line together. All right, so that means that they are not equivalent ratios. All right, look at number 7. Julie and Ryan both make purple paint. In Julie's paint, the ratio is parts blue to parts red is 8 to 10. Okay, so I'm going to go ahead and put that in the table. Hers is 8 parts blue to 10 parts red. And it wants me to complete the table to show the ratio relationship between the parts of blue paint and the parts of red paint. So this will be one batch of her paint. 2 batches, I would multiply everything by 2, would be 16 to 20. 3 batches of her paint would be 24 to 30. And 4 batches would be 32 to 40. Okay? All right. So then it says in Ryan's paint, the ratio of the number of parts of blue to red is 12 to 15. So his blue paint to red paint is 12 to 15. And it wants us to complete the double number line to show the ratio relationship between blue and red paint. All right, so we're going to complete the ratio. I'm going to start with 0, 0, and I'm going to use 12 to 15 as my first paint. You could also put 12 to 15 and reduce, go down. So we could also do it that way, but I'm just going to do 12 to 15. All right. And then if I double that, I would get 24 to 30. And then if I do times 3, 12 times 3 is 36. And 3 times 15 is 45. And then 4 times 12 is 48. And 4 times 15 is going to be 60. All right. And so the question says, do Julie and Ryan make the same shade of purple paint? And how do you know? All right, so if we look at this row right here, we have 24 to 30. Everybody see that? And then if we look right here, we have 24 to 30. And we're talking about the same thing. So we're talking about 24 parts blue and 30 parts red for both of them. So that's another thing you need to check and make sure the blue is 24 on both of them and the 30 is red on both of them, because sometimes they have the numbers correct, like 24 to 30, but they don't have it correctly as red to blue or blue to red. So you need to check that and make sure that checks out, and it does. So what does that tell us? That tells us that yes, the ratio of the number parts blue, and it should be ratios because we're talking about 2 ratios, the 24 to 30 in this one and the 24 to 30 in this one. So yes, the ratios of number of parts blue to number of parts red in both shades represent the same ratio relationship. All right, Julie and Ryan's paints. And then you want to give your evidence, right? So this is the mathematical reasoning. So yes, there are ratios of number of parts blue to number of parts red in both shades of paint, in Julie's paint and in Ryan's paint, represent the same ratio relationship. And why? Like, you want to cite your evidence. So the answer to the why is because Julie and Ryan, or Julie and Ryan's paint, both have 24 parts blue to 30 parts red. All right, so they have an equivalent ratio within their data. Julie's is in a table and Ryan's is on a double number line, but they both have that 24 to 30. So because they both have 24 parts blue to 30 parts red, that is an equivalent ratio. So that means that their two paints are going to end up being the same color. All right? And you can also test it by, you see how this one says red is 60. So another thing we could do is, okay, we can say, well, if this is 60 on here, it should equal to 48. So it should be the same on Julie's. So I'm going to add 60 to Julie's table under parts red. And how am I getting there? I'm doing 10 times 6 is 60. So what's 8 times 6? 48. And you can see that that point will also be the same because their ratios are equal. All right, and that's all for lesson 12.